So yeah, my name's Paul Burbage. Today I'll be giving you a talk on Illuminating Malware Adversaries with MalBeacon. Really excited to show and share with you today a passion project that I've been working on for over 3 years. So let's go ahead and dive in. A little bit about myself. I'm a malware researcher, and as a nice lady that introduced me mentioned, I currently work at CrowdStrike, but this particular project is not affiliated with them. This is a personal project that I've been working on myself, for over 3 years. So my passion in the field is looking at those malware kits that have some type of lamp stack and finding vulnerabilities within them. I'm a drummer, like music, of course, and I was active duty Marine 2004 to 2008. Any devil dogs in here by chance? Yeah, one back there? Simplify, brother. Yep. Good to go. Feel free to reach out to me at HackSlacks on the Twitter sphere. All right, so we'll go over our agenda for today. I'll discuss what I foresee as a problem within the malware ecosystem. It's far too easy for people to go out and acquire malware kits and utilize that to breach organizations. To understand how we're able to beacon malware command and control, I need to touch upon stored cross-site scripting just to kind of lay that foundation of how we're able to do it. Then I'll dive into the system itself, so how we're able to inject those beacon payloads into malware C2, and then what that receiver looks like, all the information that we're recording from the adversary as they log into that malware control panel. Touch upon the legality concerns utilizing this type of intelligence collection, and then have some case studies to present to you. And finally wrap that up with some conclusion and Q&A. So what is the problem? It's far too easy for anyone to go out to the internet and whether or not they're purchasing these within cybercrime forums or finding them for free, malware kits that leaked, and they can utilize these to breach organizations. And these, in my opinion, the current attribution for people that are utilizing these to attack companies, it's one-sided. It's typically grouped by shared infrastructure, shared domain registration details or shared IP addresses. Or similar tools, techniques, and procedures, as well as malware code. However, with most commodity malware kits, it's one author that's selling to several different individuals. So to trace that back to an author is one piece of attribution, but who's actually utilizing these kits to attack these companies? So there needs to be better attribution. And in order to protect ourselves, we need to understand the attacker and where they're coming from. Is it a target attack, or are these attacks occurring, across multiple industries, and they're just trying to do like drive-by download attacks or drive-by attacks to reach as many people as they can? So one way that we can do this to get better attribution is to beacon the adversaries as they utilize their malware C2. So I want to touch upon the stored cross-site scripting. So stored cross-site scripting in general is just whenever a web app vulnerability allows an attacker, in this case us, the researcher, to execute script. It's the most common vulnerability in web apps today. I was talking to the Veracode guys out there actually about some of the different web app vulnerabilities, and they confirmed that cross-site scripting is still very prevalent. And even more so in malware command and control, right? So these families, these web applications, they're not going to go hopefully through the rigorous testing that customers of Veracode would be utilizing their stack for. So this persistent or stored cross-site scripting occurs whenever that payload is persistent across the session, so it's not reflective. This is typically a payload that's stored inside the database, but can also be stored on the web server file within session information, and so on. Then it's printed out or echoed to the web application user, in this case a malware actor who's logging in to look at all the infected machines under their control. So it's printed out and it's rendered. And although it's possible within stored cross-site scripting vulnerabilities to insert JavaScript, with this particular system, we're solely doing benign image callbacks, and I'll show you why that is when we touch upon the legality concerns here in a little bit. I wanted to briefly cover what is a malware command and control? So most of these systems are the ones that we're able to insert beacons in. It's essentially just a web application. Most of the underground actors refer to these as a panel. Most of them running on a LAMP stack, so your Linux, Apache, MySQL, and PHP. So all of the infected nodes communicate. You can think of it as an API with the malware C2. This is commonly referred to as the gate. So all the infected nodes, they might check in or exfiltrate data from those infected machines and send that to the C2. The other interface allows the adversary to log in. It's usually a nice GUI, web front end where they're able to log in, see all of the infected machines under their control, and issue commands or download exfiltrated information from those infected nodes. So to give you kind of a higher level overview of what the system is doing here, we're actually pretending to be an infected node. So some of those artifacts that are submitted to a C2 might be like the workstation name. So we write code to mimic that infected node check-in protocol. And we're able to insert beacons inside of that protocol. And then hopefully if the malware C2 is vulnerable to that, the actor then logs into the C2 and it triggers an image callback. Whenever an adversary logs in, they might be greeted with a screen like this. So this is an administrative interface for form book malware. Form book, one of the families that we are collecting fairly heavy on, and I'll dive a little bit more into the case studies here in a little bit. But as you can see, further down towards the bottom, there's a couple rows, and these indicate 2 infected machines. And again, some of these fields, like the OS version there, or the bot ID to the left, that might be one of the fields that are susceptible to stored cross-site scripting, so we can insert our beacon payload into that. And then as that actor logs in, again, it triggers that image callback and we get all of the information about them. So I want to dive into the system itself. How are we able to first insert the beacons into malware C2 and then the receiver? So the beacon injection method, there's also 2 methods how we're actually able to inject this particular beacon. I kind of touched upon it earlier. So we do a manual insertion where we pretend to be a bot to check into the C2. And then we also have an automated hooking function as well within Malware Sandbox. Show of hands, is anyone familiar with Cuckoo Sandbox? Yeah, quite a few, cool. So yeah, it's just heavily modified Cuckoo. For those not familiar, Cuckoo is an open source project. You can download it for free on GitHub. It allows you to execute malware samples within a virtualized environment. It's pretty cool if you want to play with it. And then finally, there's the receiver part. So this essentially is just an image request that's coming back and hitting our systems. We're able to log all the information about the actual attacker, utilizing these malware families in the wild. Wanted to go over the injector method, or the manual injection. So this actually requires researchers to analyze the C2 source code. So we have to have a copy of that, right? We have to, some of these kits are leaked out on the internet. We can grab a copy of the kit and take a look at that PHP web application and find these vulnerabilities, and then write, reverse engineer that check-in protocol, and then create a fake bot to check in and leverage those particular vulnerabilities. So the pros of using the manual injection, it's very high precision, right? You get a nice callback rate as far as people, if the C2 is still up, by the time that you are able to inject that beacon, 9 times out of 10, you'll get a very nice beacon response from the actual person behind that particular malware campaign. Cons of this is that it's time consuming, right? So some malware families, we might find a vulnerable family, but if it's still under active development, that author might change the check-in protocol. Then we kind of have to go back to the drawing board, reverse engineer the newer version of that, and rewrite our fake bot to check in, just to see if it's still vulnerable for collections. Oops. Hopefully we didn't need that. I don't know what that was. All right. So let's talk about the Automator. kind of touched on this earlier. So it's just heavily modified Cuckoo sandbox. And the way that it works is that we're able to rewrite the monitor for the executable and the DLLs that get injected to monitor the behavior of malware samples as they're being ran within this virtualized environment. So what we do is hook these Windows API functions. The malware sample, as soon as it fires, it might say, give me the machine name or give me the username of the Windows computer that I just infected. So that would be like a Windows API call, like get username X. So we hook that function, and on the return, we taint the response to that with our beacon payload. Again, that might be one of the artifacts that are submitted up to the C2, and if it's vulnerable, it would pop and give us telemetry on who's used in the actual C2 there. So the pros of this is that it's highly scalable, right? We can scale out Cuckoo to run not hundreds but thousands of samples, discover new families in the wild that we might not have the source code to analyze for vulnerabilities. And then from there, we can take a look at the ones that we're getting callbacks for, and then fine tune and reverse engineer that particular malware family to develop a little bit, better check-in protocol for the manual injection. So it kind of feeds itself, right? The cons of this, though, is that it's quite noisy. And the reason why it's noisy is that it's a best case scenario that a malware family is not susceptible, it's not vulnerable, is that that initial gate or the malware check-in protocol, it just drops that connection. It says, this is a bad input, I'm not even going to try to process it. Drop it, goodbye. Worst case scenario, though, is that information is still stored into the database, but the particular field is not vulnerable to cross-site scripting attacks. So now we have a URL, our benign image callback, that's not properly rendered as HTML, so they can see those domains, our infrastructure that we're utilizing for callback. So obviously a bit of an OPSEC concern there. Then again, so as that malware C2 person who's conducting these campaigns, as they log in to look at all of the infected machines, they're going to trigger these image requests back to our systems. And what we stood up is just an image, another web application to record those image requests. When I first started looking at this, I was amazed at how much information you can get just from an image request. Really opened my eyes up to the amount of information that advertisers have on each and every one of us. So what the receiver is just an Apache with some HD access hacks. Image request comes in, redirect that GIF to a PHP script, and now I'm able to do some stuff programmatically as far as all that information is concerned. Pulling out the source IP address, which of course can be geolocated in the event that it's a true IP address. Questions that I received in the past, are actors utilizing VPNs? The answer is yes. But just knowing what VPN provider your attacker is utilizing, I think that's a pretty unique intelligence aspect in and of itself. What are some of the other fields? The HTTP refer field is probably one of the most interesting. So the refer field, this is going to be the actual C2 address of the malware campaign, or of where the malware actor is currently logged into. So that's always pretty cool to see. And we get the complete get parameter that they're utilizing as they're browsing around on the malware C2. For some of the manual injection methods, I'm able to submit a unique ID parameter. So this is really interesting, especially in malware families where you might have multiple proxies in between the infected nodes and the C2. So receiving a UID response and that initial gate URL is different than the UID response, HTTP refer, that indicates that this is a completely different back-end infrastructure that the bad guys are utilizing, stuff that you wouldn't see from typical, running malware samples just in a sandbox to retrieve those indicators of compromise. And some of the crappy, there's browser add-ons that some people, place that, or they utilize free HTTP or HTTPS proxy list. some of those proxies actually leak the true IP address of the individual. So they might think that they're utilizing these free proxies to obfuscate their true origin, but within that proxy request, they include headers of that true IP address. So if we see that, we obviously log that particular IP. And then the user agent. Of course, all of these client headers can be forged, but if the user agent is true, that tells us quite a bit of information about our adversary. Everything from the architecture that they're utilizing, x86, 64, whether or not they're coming from a mobile device, the operating system in use, and their preference in web browser. So the script just records all this, saves it to a database for later review, and then we send back a one-by-one pixel image. Why do we do this? Because as long as that cross-site scripting field is rendered properly, we just want to send back a one-by-one pixel image, hopefully to not mess up any of the HTML formatting as that actor's looking through their C2 web application. So hopefully the actor's none the wiser that there's a tiny one-by-one pixel being rendered there on their C2. And then probably one of the coolest artifacts that I implemented earlier this year, I was discussing with some researchers in the field, and they're like, Paul, why aren't you placing a persistent cookie in the reply to that image request? And that's exactly what I implemented. And I'm seeing some really nice clustering from this data. So again, going back to how we're starting to, the old ways of attributing, I have this malware sample, it communicates with this domain, and I found this other domain that was registered with the same email. Yeah, that might be an indication of the same threat actor group, but now we're able to track these browser sessions as they log in to new C2s. So they can change the domain. We can track the movement of that. We can start clustering C2s together to form like this picture here. And this data was actually just generated last week. So what I did was map the C2 host and the persistent cookies. And what this indicates is that 562 unique domains or IP addresses can be attributed to one threat actor group. And previously looking at this, you wouldn't be able to draw those conclusions. It would just look like a bunch of commodity malware that's hitting organizations' networks. And we've actually been able to attribute to a lot of this activity to Silver Terrier. So Unit 42 publishes a report usually about once a year. Most of these guys doing business email compromise, but also dabbling in LokiBot malware, Formbook malware. But yeah, it was pretty cool to draw that to that one threat actor group, mainly operating out of Western African nations like Nigeria and Cameroon. So let's discuss the legality of utilizing this type of collections apparatus. So I actually went several rounds with the EFF, the Electronic Frontier Foundation, and I wanted to get their opinion. How far can I get away with doing this? And they said, as long as you're not doing code execution, which in this case would be JavaScript, you're good to go. Which is it was kind of a letdown, because in the event that we were doing JavaScript, we could do some pretty cool things like, I don't know, request access to the adversary's webcam, take a picture of it. There's a company just off the top of my head called SessionCam that records video of what's occurring inside the web app. So we could take like an MP4 of everything that they're doing inside the malware C2. But again, that unfortunately utilizes JavaScript and is a little bit out of bounds for staying legal. So I wanted to keep this system ethical and legal. That way I could talk to you all about it here today. So it's no worse than advertisements either. I bet each and every one of us, if we pulled up our phone and take a look at the raw source of the emails on the phone, you'll find these benign image callbacks to tell the advertisement companies whether or not, or tracking companies, that you opened that email. No worse than that. There's no authentication bypass. Again, in the event that we were doing JavaScript, we would be able to grab those authenticated cookies and then utilize that to authenticate against the C2. But since we're not doing JavaScript, we're not able to grab those cookies and do that. Wouldn't recommend that. And it is privacy respectful. So again, these are beacons that are solely submitted through a bot check-in protocol, and the only way for them to be tripped is if you're the adversary that's logging into these malware C2s. You wouldn't be, tripping these beacons just by ordering blow-up dolls on Amazon. Good to go? So let's dive into some case studies here. I believe BlueLive called this group Air 9, and maybe Talos, or maybe it was Unit 42 actually calls them TA545. Again, I've been collecting this data for over 3 years. Back in January of 2018, some groups of knuckleheads were utilizing the onliner spam bot to send email attached with CanadaPost.zip. The zip contained R's VBS loader, which is actually a commodity malware family that was sold in Russian underground forums. Pictured right as that the C2 login for that. So it was just a VBS that when that victim clicked on it, it reached out to the C2 and asked, what additional malware would you like me to download and execute? And the underground vernacular actors call this a loader, right? So this particular campaign, it was loading Canadian banking Trojans. They targeted, Canadian financial institutions users, as well as deploying Zero Evil Stealer, the same author actually, Zero Evil, the same author behind R's VBS loader. So received some pretty interesting callbacks on this one from a dedicated server hosted in the UK, Five Eye friendly nation, right? So reached out to the Canadian CERT folks. They were pretty interested in getting that piece of intelligence. Taking a look at the IP address at the time across Shodan, indicated that it was a Windows 10 box, and the same thing with the user agent there as far as the callback. So that was pretty good attribution for this particular case. So they were actually utilizing this dedicated host in the UK as a bounce box to conduct their malware campaigns. Second case study, back in September of 2018. This is actually an ongoing threat. I see it probably at least 2 or 3 times a month, where guys will go out, bad guys will go out, they'll take a look at popular crypto coin wallet software. They'll copy that website, stand up a fake one, and by tricking users via SEO or advertising that link in crypto forums, they'll trick people to visiting these websites to grab the new edition of this software. In this particular case, it was downloading KPOT Info Stealer. KPOT is actually an info stealer sold in Russian underground forums. KPOT, actually pronounced krot in Russian, means mole. This particular campaign tracing back to a VPS provider in Russia. So this not only works with commodity malware, the system has also recorded advanced persistent threat groups, APT activity. Back in January of this year, a piece of mole rats malware came across my desk. And this was one of the families that we obviously didn't have the C2 source code for, but I tossed the malware sample into the hooked sandbox, the modified sandbox, and received some pretty nice attribution callbacks from this particular campaign. IP address tracing back to Gaza cyber gang, it was geo-traced back to the Gaza Strip, and of course mole rats has been attributed to the Gaza cyber gang. One pretty cool artifact in this particular campaign is that in order to render the backend C2 panel there down at the bottom, you had to set that particular user agent of 2s. So I thought that was a pretty unique string, and sure enough, searching that string across social media profiles may or may not have found a couple people attributed to this particular cyber gang. Just wanted to briefly touch upon the current statistics. Over 3 years, unique IP addresses that I've collected, over 28,000. Beacons received, so this is each page refresh that's sending an image request, over 355,000. These stats were pulled yesterday morning. And I've identified over 32,000 C2s. Wanted to give a shout out here to this slick front end graphics that you see. Here's one of my good friends, Chris Court, who programmed that. So he'll probably watch this later. Can everyone say thanks, Court? Thanks, Court. Awesome, thanks. He'll get a kick out of that. Appreciate it. So in conclusion, some of my future work that I want to take a look at is, really scaling out that automated sandbox. Cuckoo itself supports like a distributed mode, so I'm looking to, get past the, just doing like hundreds of samples today and take that up to thousands. Run several samples through, see what kind of callbacks we get, and then we can go back and reverse engineer those particular check-in protocols and fine-tune the beacon responses for that. The clustering of beacons, so if anyone in here has a data science background, I'd really like to understand how we could, apply some machine learning models, start clustering these threat actor groups into, actionable intelligence to hand off not only to LE, but also, cyber threat intel teams, so on. So that being said, I'm currently working on an API as well as like a MISP feed. So if you're into threat intelligence, the front end, the website snippet that I showed you earlier, you can request access to it. Right now it's just, you can log in and search for the data, but eventually we'll have like a malware submission where you can upload samples and we'll attempt to run it in our malware sandbox so you can hopefully try to get beacons back on that. So the short URL there, it doesn't go to a Rickroll or anything. You can hit up that short URL to a Google form, just request some information to verify who you are or where you might work, just to verify I'm not giving access to any bad guys is all. That's about it. Thanks for having me. Got through that pretty quick. Did anyone have any questions or concerns? Yeah, I would like to. So the question was, have I considered any other type of beacons beyond image callbacks? Yeah, that was one thing I was hoping to do with JavaScript. So with JavaScript, especially utilizing like WebRTC. So WebRTC is notoriously known to sometimes circumvent VPNs. So by issuing a WebRTC request from a victim's machine, if they have a pretty crappy VPN provider, they don't filter those properly, and you can get a true IP address back from that. But unfortunately, again, that's utilizing JavaScript, so it's kind of out of bounds. Yes, sir. I'm sorry, could you repeat that? Oh, that's interesting, yeah. So the question was, have I considered utilizing long domain names to see if there's any DNS leakage? Yeah, that's a really cool idea. The only issue, well, that could work for some of the manual injection methods. With the automated version, we have to have a very small payload, right? Because the Windows kernel will crap out, like if you do a payload longer than the Windows username field, which is like 22, 25 characters or something like that. So very small payload, but I do see how that could be very beneficial for manual insertion techniques. That's cool. One other thing that I'm kind of playing with is, show of hands, anyone familiar with Jaw 3 at all? Nobody? So Jaw 3, it's an open source project, I think published by Salesforce. What Jaw 3 does, it attempts to fingerprint the web client. And the way that it does this, each web client is built with an SSL library. And the way the connection occurs, the particular order in which these crypto libraries are compiled can be fingerprinted. So Jaw 3 is able to fingerprint like the difference between Chrome SSL connection compared to other browsers. So I'm looking to implement that, but that's more on like the network layer side. But there's also like other OS or TCP fingerprinting that I could implement. So taking a look at that network stack as well, I think it'd be pretty beneficial. Any other questions? Good to go? All right. Thanks for your time.